Uh, Good morning, guys. Good morning, grade 11. I hope that you enjoy with our chemistry session today, inshallah. Now, inshallah, we are going to take a new lesson, including heat and energy, which is called what is called calculating enthalpy change. Listen, please.
Section 4, Calculating Enthalpy Change. The enthalpy change for a reaction can be calculated using Hess's law.
So we can calculate enthalpy change for any reaction by using Hess's law. It's called what? It's called Hess's law. Okay. After that, listen please, the essential question that you are going to study in this session.
Essential questions. How is Hess's law applied to calculate the enthalpy change for a reaction? What is the basis for the table of standard enthalpies of formation? How is delta HRXN calculated using thermochemical equations? What is the enthalpy change for a reaction using standard enthalpies of formation data?
Okay, so this is a question that you are going to explain in this session. How is Hess's law applied to calculate the enthalpy change for a reaction? What is the basis for the table of standard enthalpies of formation? How is delta H calculated using thermochemical equation? What is the enthalpy change for the reaction using standard enthalpies for formation data? Okay, who can read? Abdulrahman, Abdulillah first. Can you read Abdulillah, please?
Yes.
Read the first question.
Okay. How is Hess's law applied to calculate the enthalpy change for a reaction?
Okay, thanks. Abdullah, can you read, please, Abdullah?
What is the basis? The table of standard enthalpies of formation.
Okay, thanks, Abdullah. Abdurrahman, can you read third question? Abdurrahman.
Yes, mister. How is H
Delta H.
delta H RXN
Yes.
calculated using thermochemical equation?
Thermochemical equation.
Thermochemical equation.
Okay, thanks, Abdurrahman. Walid.
What do you want me to read?
Read, Walid. What you want? Read, Walid. What is the paragraph that follow?
What is the enthalpy change for reaction using standard enthalpies of formation data?
Okay, Walid. Is you, Walid? Are you Walid? Or no?
Yes.
But I didn't think that. I think that it's your brother. Not the voice of Walid.
It's still me. Don't worry.
Sure, Walid? Sure?
Yes.
Okay, Walid. Okay. Thanks. After that, we are going to show the vocab that we are going to study. Vocab that we studied called allotropy. Okay, allotropy. But the new vocab that we are going to study, this is, listen please.
New. Hess's law. Standard enthalpy, heat, of formation.
So this is the vocab that we are going to study. Hess's law, standard enthalpy, heat of formation. It's okay? It's okay. Let's go now. Hess's law. What's meant by Hess's law? Okay, listen please.
Hess's law. Hess's law states that if you can add two or more thermochemical equations to produce a final equation for a reaction, then the sum of the enthalpy changes for the individual reactions are the enthalpy change for the final reaction.
Okay, so it's the concept of Hess's law. It's very important. Hess's law means that if you can add two or more thermochemical equation to produce a final equation for the reaction, then the sum of the enthalpy change for the individual reaction is enthalpy change for the final reaction. Okay, so individual reaction, the enthalpy change for the final reaction. Sum of the enthalpy changes for the individual reaction is the enthalpy changes for the final reaction. Okay, this reaction as a 2s solid plus 2O2 gas as burning of it. So we are going to get what? 2SO2 gas, K plus O2. But first 2SO2. After that, O2 gas. Okay, this is the equation. This is equation number C, and this is equation number D. It's okay. So this is the equation as sciences of sulfur trioxide. Sulfur trioxide. Okay. Who can answer me what's meant by Hess's law? Hussein, can you read please, Hussein?
Hess's law states that if you can add two or more thermochemical equations to produce a final equation for a reaction, then the sum of the enthalpy changes for the individual reactions is the enthalpy change for the final reaction.
Okay, thanks, Hussein. Khalid Satam.
Do you want me to read again, mister?
Can you read, please?
Hess's law states that if you can add two or more thermochemical equations to produce a final equation for a reaction, then the sum of the enthalpy changes for the individual reactions is the enthalpy change for the final reaction.
Okay, thanks, Khalid. After that, after this enthalpy, okay, we are going to go a problem as how can we solve this problem? Okay, use thermochemical equation A and B below to determine delta H for the decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide, H2O2, a compound that has many uses ranging from bleaching hair to powering rocket engines. Okay, rocket engines. 2H2O2 to H2O2, okay, it's a liquid. Okay, it's called what? 2H2O2, called hydrogen peroxide. Hydrogen peroxide that can be used in preparation of oxygen gas. Hydrogen peroxide can be used in preparation of oxygen gas. Okay, so 2H2O2 produce 2H2O liquid plus O2 gas. But in the first, okay, it will make a reaction between 2H2 as gas plus O2 to produce 2H2O. And delta H will be negative 572 kilojoule. After that, H2, another H2 gas, will react with O2, okay, to produce H2O2, it's a liquid. And delta H equal what? Delta H equal negative 188 kilojoule. So, you have been given two chemical equations and their enthalpy changes. These two equations contain all the substance found in the desired equation. So, the known is the first and second equation. First equation, 2H2 gas plus O2 gas produce 2H2 liquid, and delta H equal 500 negative 572. The second H2 gas plus O2 to produce H2O2 liquid, and delta H equal negative 188 kilojoule. But the unknown delta H, how can we get it? Okay, H2O2 is reactant. So H2O2 produce H2 plus O2, and delta H equal 188 joule. Reverse equation B and change sign of delta H. Change sign of delta H. After that, 2 moles of H2O2, these 2 moles of 2H2O2, okay, produce 2H2 plus 2O2. Multiply the reversed equation B by 2 to obtain equation C. Okay, multiply the reverse equation is multiply by 2. So H2O2 will be 2H2O2. H2 will be 2H2. O2 will be 2O2. So we made multiply the reversed equation B by 2 to obtain equation C. Okay, after that, delta H for equation C equal 188 kilojoule, but by making times 2, it will be 376. Okay, multiplying 188 kilojoule by 2. Why by 2? To obtain equation delta H of equation C. All right, equation C and delta H, so 2H2O2 aqueous solution produces 2H2 gas plus 2O2 gas, and delta H in this stage equal 376 kilojoule. Add equations A and C, cancelling any terms common to both sides of the combined equation as the enthalpies of equation A and C as. All right, equation A, 2H2 plus O2 to produce 2H2O, and delta H equal negative 572. All right, equation C, 2H2O2 produce 2H2 gas plus 2O2 gas, and delta H equal 376 kilojoule. So we wrote equation number A and C. Okay, add equation A and C to the enthalpies. So delta H, 2H2 delta H equal what? Equal the plus of this equation. Okay, the two equations produce the desired equation. All values are accurate to the one place, so delta H is correctly stated. It's okay. This is the problem that we studied. Standard heat of formation. What about the standard heat of formation? Okay, what about the standard heat of formation? First, please, we are going to show this. Oh, there is no source here. It's okay. Excuse me, guys. Now, inshallah, you are going to complete. Okay, who can read the standard enthalpy or heat of formation? Who can read heat of formation? Okay, Khalid. Khalid Harbi. Khalid Harbi. Can you read,
Yes,
please?
sir. The standard enthalpy heat of formation is defined as the change in enthalpy that accompanies the formation of one mole of a compound in its standard state from its elements in their standard state.
Yes. Okay. Thanks. So this is called standard enthalpy heat of formation. The standard enthalpy heat of formation is defined as the change in the enthalpy that accompanies the formation of one mole. That accompanies the formation of one mole of the compound. In its standard state from its element in their standard state. So elements in their standard states have delta H formation as elements in their standard to be formed. Okay, so delta H will be 0 kilojoule. The formation of compounds are placed above or below element in their standard state as what? This is okay, delta H of delta HF, H of formation. Okay, so NO2, it's a gas. Okay, N2 and O2, S, so they are elements. Okay, to form SO3, to form SO3. Okay, and NO2. So it's delta H formation of SO3, delta H formation of NO2. So this is the element that will form this compound. So delta H equals 0 in this element. So the enthalpy, standard enthalpy of formation of any element equals 0. After that, they will form compound. This is equal 0 to form NO2. So delta HF means delta H formation of NO2 equal plus 33.2, while delta HF equal 30. Okay, so this is the HF of SO3 and this is the HF of NO2. Listen please to this.
Standard enthalpy, heat, of formation. The standard enthalpy, heat, of formation is defined as the change in enthalpy that accompanies the formation of one mole of the compound in its standard state from its elements in their standard states. Elements in their standard states have the formation of compounds are placed above or below elements in their standard states.
It's okay. Understand this? Any problem till now? It's okay. So this is called standard heat enthalpy of formation. After that, the standard enthalpies of formation, okay, as standard enthalpy of formation can be used to calculate the enthalpies for many reactions under standard conditions by using Hess's law. What about Hess's law? The summation equation, delta H equal total delta HF product minus this total delta H formation of reactants. Delta HF product minus delta HF reactants. This is compound. Okay, this is a formation equation. Okay, and this is delta H. H2S. Okay, the equation of its formation is H2 gas plus S gas to produce H2S, and delta H equal negative 21. Delta half H2 means what? Half H2 means one hydrogen atom, plus half F2 means also one fluorine atom to produce HF. to produce HF as gas state, and its standard heat or standard enthalpy of formation of HF equal negative 273. S plus 3 over 2 O2. Okay, 3 over 2 O2. 2 with 2. Okay, reduce 2 with 2 to be O3. So it will be SO3 equal negative 396. Okay, SF6 produced by S plus 3F2. So it will produce SF6 and equal negative 1220. So it's a standard heat. Listen, please.
Standard enthalpy, heat, of formation. Standard enthalpies of formation can be used to calculate the enthalpies for many reactions under standard
Okay, Musa, can you read Musa, please?
Standard enthalpy of formation.
Yes.
Enthalpies of formation can be used to calculate the enthalpies for many reactions under standard conditions by using Hess's law.
It's okay. Thanks, Musa, for your participation. So it's called standard heat of enthalpy. Okay. After that, meeting will 10 minutes. It's okay.
conditions by using Hess's law. The summation equation.
It's okay. This is called summation equation. Okay, as this problem, listen please. Use standard enthalpies of formation to calculate delta H for the combustion of methane. The equation will be CH4 gas is methane gas plus 2O2. 2O2 means by burning methane. I said before that any chemical reaction that will be with O2, so it means burning. It means burning. So how can we burn CH4? By O2. So by burning methane gas, CH4 gas plus 2O2 gas to produce CO2 gas plus 2H2 liquid. You are given an equation and asked to calculate the change in the enthalpy. The formula delta H equal total delta H product minus total delta H reactants. Can be used with data from table R11 that we explained before on the next slide. Okay, so delta HF of CO2, delta HF of CO2 equal negative 394. Delta HF of H2 equal negative 285. Delta HF of CH4 equal negative 75. But delta HF of O2 equals 0. Why? Who can answer me? Who can answer me why delta HF of O2 equals 0? Hussein, okay, Hussein? Yes, Hussein.
Because it's in its standard form.
Because what?
Because oxygen is in its standard form.
Yes, it's standard because O2 is an element. So there is no standard heat of formation because it's element. But CO2, it's a compound. H2O, compound. CH4, compound. But O2 only is the element. So it has no enthalpy formation of heat. Okay. Thanks, Hussein, for participation. Yes, Hussein.
How do you find the heat of formation for the elements, for the compounds?
There would be no enthalpy, no heat enthalpy of formation of any element because each element produced as this shape. Okay, this shape, not formed. okay, as O2. O2 it's found in our surrounding area as O2. So there is no formation for it. But the formation will be only for any compound to be formed. It's okay?
Okay.
So enthalpy formation of any element must equal 0. After that, solve the unknown, use formula delta H equal total delta H product minus total delta H reactants. Expand the formula to include the term for each reactant and product, multiply each term by the coefficient of the substance in the balanced chemical equation as substitute CO2 and H2O for the product, but CH4 and O2 for the reactant. Multiply H2O and O2 by 2. Okay, so delta H will be delta H formation of CO2 plus 2 delta H formation of H2O, this product. We said that as Hess law, so delta H equal delta H formation of product minus delta H formation of reactants. Okay, so the product will be what? The product will be as this. Okay, delta HF CO2 plus 2 delta HF H2O minus delta HF CH4 plus 2 delta HF of O2. Okay, so this is the concentration of aqueous solution. One more, heat of formation value. Okay, it's for illustration only. For illustration only. Don't be saved. Don't saved. It's okay. So delta H equal negative 394 kilojoule plus 2 times negative 286 kilojoule minus bracket negative 75 kilojoule plus 2 times 0 because it's oxygen gas. By calculating it, okay, delta H, it will be negative 966 minus negative 75, okay, to be negative 966 kilojoule plus 75 will equal finally negative 891 kilojoule. So the combustion of 1 mole CH4 released about 891. Okay, we didn't write the negative. Why? Because we said that it's released. Word release means that it's a negative. Okay, word release means it's negative, so we didn't write sign negative in 891 kilojoule. After that, this is the equation. Okay, this is a standard enthalpy of combustion. Okay, standard enthalpy of combustion. Now, inshallah, I think that we finished our session. Okay, thanks guys for your participation. Okay, and I think that all students must answer the quiz today, inshallah, at 8 p.m. From 8 to 9 p.m. Okay, and good luck for all guys, and I hope that you will enjoy your time, inshallah. Khalid, yes, Khalid Satam, what do you need, Khalid?
Mister, the quiz, how long is it gonna be? Then goes down.
Okay, quiz what? Quiz what?
How long will the quiz be up?
1 hour, 60 minutes. Only 1 hour, from 8 to 9. From 8 p.m. to 9 p.m. And after 9, it will be closed automatically. And evaluate yourself. Okay? Okay.
Thank you, Mister.
Thanks, guys. Thanks, guys, for your participation. Enjoy your time. See you soon, inshallah. And good luck. Okay? Goodbye, guys.